Hello, I'm Zhang from K University. Today, I'd like to talk about ReflecTouch, detecting grasping posture of smartphone using corneal reflection images. We developed a novel method for detecting how a smartphone is being held by capturing face picture with a built-in front camera. In smartphone screen, the areas that are easy to operate with the thumb are called the thumb zone. However, while many smartphone applications are designed to operate with the right thumb, they may be difficult to operate when the phone is being held in other ways. By determining how a smartphone is being held, it is possible to adjust the screen display, switch button positions, and launch applications and functions automatically regarding the grasp posture. Several methods for determining grasping posture have been proposed previously. However, these methods have their challenges. For example, these require external sensors, need to implement machine learning models for each device model, and detect only a small number of postures. To address these issues, we propose ReflecTouch, a novel grasping posture detection method. When a user operates a smartphone, the screen emits light, so the user's cornea reflects the smartphone screen. In the reflected image, the area where the user places their finger on the screen is missing and appears as a shadow. ReflecTouch acquires the reflected image from the smartphone's front camera to estimate the grasping posture. As you can see, the corneal reflection image is different between grasping postures. Our method requires no additional hardware. In addition, the effect of using different smartphone model is limited because most of smartphone has similar shape and has built-in front camera in similar position. Our application captures a face image using front camera while the user is operating their smartphone. Then it crops the smartphone image reflected on the cornea. Cropping is done in two steps. First, it crops face picture to the pupil area and then crops it to the area where the smartphone is reflected. After cropping, it will apply filters to image to adjust brightness and contrast of image. After this pre-processing, images are used to train CNL model. When training is finished, we can use the model to detect grasping posture. We conducted the data collection experiment to train that CNL model and evaluate the accuracy of our system. We developed a smartphone application that takes face picture of users holding a smartphone in each grasping posture. Using this application, each participant took 12 selfies per grasp posture, in total 72 pictures. Using the collected image, we implemented the CNL model and evaluated the accuracy. On average, the accuracy of all user learning was 84%. From the confusion matrix, we found that the thumb and index finger of each hand were sometimes confused. We assume this is because whether the user was operating with the thumb or index finger had no significant effect on the shadows. The accuracy of other user learning was 43%. The possible reason for the low accuracy of other user learning are individual biological differences such as eye color and light reflection, as well as the position of the smartphone and the brightness of ambient light when taking pictures. In the first experiment, we used 72 pictures per participant. Considering actual use, it may be a burden to take 72 pictures for user. So we did transfer learning experiment to achieve the high accuracy with fewer photos. Using transfer learning technique, we achieved 76% accuracy with only 24 pictures. This video is demonstration of application using our method. Smartphone application can switch the menu position according to grasp posture. Also, it is possible to switch keyboard mode to most suitable for the current grasp posture. According to prior research, using smartphones for a long time can cause pain in the finger or cause certain physical symptoms. In the system shown in the video, can provide feedback to the user according to usage time of the grasping posture. Our method has some limitations. In current system, screen flash is needed when taking picture to ensure that the light from the smartphone screen is reflected on the cornea. We need to verify the accuracy without screen flash. Also, other strong light source, such as monitor or tabletop light, affects grasping posture detection. The light image shows the corneal reflection images when there is tabletop light. To solve this limitation, we need to differentiate other light source and detect smartphone screen by computer vision technique. As a conclusion, we developed a novel method for detecting how a smartphone is being held with 84% accuracy. Thank you.